Hello and welcome to yet another Flat Earth busting video. Now you're watching a video I shot of the sun setting. Now of course all sunsets and sunrises for that matter prove that the Earth is not flat. But there's something quite special about this particular sunset, and it challenges the bogus claims that flat earthers like to make about the setting sun. So let's examine it in a little more detail. I think that most people realise all sunsets and sunrises prove that the Earth is not flat. If the Earth was flat, with the sun circulating above the Earth, then the sun would have to be relatively small and only a few thousand miles above the Earth. If this were true, then the sun would appear to get progressively smaller as it sets before eventually disappearing at a point just above the horizon. As you can see from this footage and many other examples that are available on the internet, the sun does not appear to get progressively smaller as it sets. It sets by appearing to drop behind or below the horizon. Of course, those who peddle the flat earth big lie realise this, so they've come up with several bullshit claims in an attempt to hoodwink the gullible. This particular sunset exposes those claims as untrue. And that is my aim with the videos I produce. It is to expose the big lie of flat earth and thereby expose the charlatans, con men and women behind that lie. So before I explain why this sunset destroys some of those claims, let's list the ways in which flat earthers like to claim sunsets are possible on a flat Earth. So the first claim, made by people like Eric Dubay, is that the sun does appear to get progressively smaller as it sets. This is demonstrably untrue, as you've seen in this video, and others have done a much better job by using solar filters to demonstrate that such claims are indeed completely false. Please do not be taken in by footage in which the sun has been overexposed so it appears larger earlier in the day, and then the amount of light from the sun appears to get less as the day wears on. It's simply fiddling with the exposure setting to make it appear like this, when indeed it is not the case. So the second flat earth claim about sunsets is to do with objects appearing to disappear from the bottom up as the sun does at sunset. And the claim is that the angle at which objects are observed causes them to seem to disappear from the bottom up, even though they're not. And the smaller the angle, the greater the amount of the object that appears to be hidden from view. Now, this video will address this particular claim directly and show that it is false. A third claim that I have heard is that the atmosphere magnifies the sun, or possibly a dome over the Earth, magnifies the sun in such a way that the normal effect of angular size reduction due to distance is counteracted in such a way that the sun always appears to be exactly the same size, even though it is in fact moving away. And this claim is also false. I'll present some evidence here in this video that I think contradicts that claim. But it's an incredibly difficult claim to deal with directly because it's a case of a kind of special pleading. The claim is that the sun is affected like this, but that other things are not affected in the same way. Of course, there may be other claimed explanations by flat earthers for how the setting sun is possible on a flat earth, and if so, please feel free to post them in the comments and I'll try to address them in future videos. But for today, I'm really going to mainly deal with this idea that the angle at which an object is observed causes it to disappear from the bottom up. So you might be wondering what's so special about the particular sunset that I filmed. One sunset surely is much like any other sunset filmed over water. Well, first of all, let me show you where I was located. So as most of you will know, if you're new to the channel you don't know, I live in Scotland. I live in this part of Scotland here, which is called Fife. And when I was filming, I was actually in the town of Anstruther, on the harbour wall at Anstruther. So we'll scroll in to get to the harbour wall. And I was on the harbour wall just here, and you'll see this portion of the harbour wall and the beacon feature hopefully a little later in the video. My camera was positioned just on the end where I could get some shelter behind the higher wall here. There's no wall along this section, there's just a pipe runs along the end there. That's a mooring rail type pipe thing, I think. Anyway, if we, so I was looking in the southwesterly direction. It was January the 31st, and I've drawn in a line here, and that line goes to a point in the distance. So we're looking out over the water of the estuary here, and the line goes to this point near to South Queensferry, and this is a hill called Mons Hill, and it has an elevation of 115 meters according to Ordnance Survey maps. I'll show that again later, and 106 comes up on Google Earth. So now if we look at the same location on Peak Finder, so I set the date and the time, and the camera location here will zoom in to get it accurately onto the end of the pier at Anstruther. In fact, we seem to be pretty good. I must have got this set up before. So this is where the camera was located, and if we click go to, it shows us all the peaks that we should be able to see in a kind of 360 around from that location. And I've clicked here to put the setting sun and the setting moon on, and it gives you the time of sunset as being 1638. So Peak Finder shows us we have a clear view of the water to the water horizon, and suggests that we should not be able to see any peaks behind the setting sun or in front of the setting sun. We can check that there really are peaks there by elevating the camera height. So the camera elevation is set to 0 feet above the ground at the moment. So it's using the ground height elevation. Now I was a couple of, probably about a metre higher than that, but that's not going to make much difference. But if we move up, say 20 metres, which is the smallest it seems to let me do, and click on around, and we'll zoom in a little, Still, we've got the sun not being seen, and not seeing any hills in front of the sun, between the sun and us. So let's go up to 40 meters. Elevation, and now we can see that there are indeed hills, and the hill that we pointed out on Google Earth, Mons Hill, should indeed be between us and the setting sun. So we know that this is the correct direction, and Peak Finder shows us the sun would set, the point is just about touching the horizon. Mons Hill should be directly between us and the setting sun. Now, if the Earth was flat, we should be able to see Mons Hill, even with the camera down at 0 feet. Whereas on a spherical Earth, as Peak Finder is modelled on a spherical Earth, what we should see is a clear water horizon with no land between us and the setting sun. So I think this particular sunset is quite unusual, in that we are looking towards some land which is less than 50 kilometers away, and we're actually unable to see that land at all. Now, flat earthers have to come up with an explanation for this. Why is the land, why is Mons Hill not visible between us and the sun, or between the camera and the sun? It should appear silhouetted here on the horizon, but it doesn't. Now, there are a couple of possibilities that flat earthers have offered. I mean, they're completely bogus, but let's deal with things that have been suggested before. So one suggestion for similar observations has been that the angular size of the object we're looking at is too small to be resolved. Clearly in this picture the waves are visible at the horizon, and so one would expect a 115 metre tall hill to also be visible. But as we shall see in a minute, there is another reason for knowing that a 115 metre tall object should indeed be visible at 50 kilometres. The second possibility that flat earthers have liked to suggest is that the angle at which we're observing the hill is so acute, so shallow, that the hill begins to disappear from the bottom up, although they've never explained why, and at this angle the whole of the hill is actually obscured from our view. Now, once again, this is a completely false and bogus claim, but it is one that they like to make, and I think we can prove that this is simply not the case. So we've moved on a little bit further in the video here. I think this is now been slowed down, so you'll see the birds flying past at rather more normal speed. The previous clip was sped up, and as the camera zooms back out and the exposure levels going to be changed, and we'll pan across to the left, some other objects will come into view, namely some wind turbines. Now, these wind turbines are around 76 76 kilometers from the camera, so they are around 30 kilometers further away than Mons Hill, And the wind turbines are around 100 metres tall. Most onshore wind turbines are in wind farms are around 100 metres or so tall. Some a little bit more, some a little bit less. I haven't identified which precise turbines are in this wind farm that we're looking at now to get the precise height, but they are around 100 metres tall. That's from the base to the tip of the blade when the blade is in a vertical position. Well, we can clearly see these at around 100 metres, even though they are 30 kilometres further away. So if we can see these, then we ought to be able to see Mons Hill. Clearly we can't see Mons Hill, and so the angular resolution argument is completely destroyed by the observation of these wind turbines. So flat earthers have a big problem there. So now let's deal with the claim that has been made that objects disappear from the bottom up because we view them from a very acute angle. The suggestion would be that Mons Hill is not visible because the angle that from which we're observing it, or at which we're observing it, is so acute that it disappears from the bottom up, such that none of it is any longer visible. Now, of course, no evidence has ever been presented to support such a claim, and it simply isn't the way that light and optics work. However, let's concede that that might be a possibility, that the angle from which we're observing causes something to disappear from the bottom up. We'll just concede that for the sake of argument. I'd like you to notice in this sort of blown up part of a still frame from the video, the structure on the right hand side next to the right handmost turbine. In a previous video I identified this as the top of the lighthouse tower on the island of Inchkeith. So let's have a look at that and see what it tells us about our angle of observation. So here we are back on Google Earth, and this is the island of Inchkeith. I've drawn in a line there in white to the lighthouse, and I'll just scroll in so that you can see that I have indeed placed the line to the base of the tower of the lighthouse here. Now, using Google Earth, we can measure the distances to Mons Hill and the distance to the lighthouse. So the distance to the lighthouse, Anstruther to Inchkeith, is 34.3 kilometres. And the distance to Mons Hill, this is the red line, is 48.4 kilometres. And we can use those distances to calculate the angle that we are looking at to see the top of the lighthouse, and the angle that we would be looking at if we could see Mons Hill. So those of you who know me will be very aware that I don't like using math because I'm not very good at it, but it's useful, and we need it here. So there is a formula for calculating the expected angular size of an object, and this is the formula. We have an angle, or actually a sum of two angles here, and that's why there's a 2 in this equation there. and the size of that angle is determined by both the height of this object and the distance that it is away from the observer. Now you could argue that on a flat Earth, with us looking at an object in the distance, a simple right-angled triangle actually accurately represents what we would be expecting. So I've drawn this with the angle here, theta, and the height of the object h and the distance capital D. And all we need to determine the size of this angle is some very simple trigonometry. So this angle is given, or the tangent of that angle is given by h divided by d, and taking the arctan of that gives you the angle in degrees. You can convert to radians if you like. So this angle is the crucial thing as far as flat earthers are concerned. So what flat earthers say is two things. Firstly, if that angle is too small, you can't see the object in the distance because the human eye can't resolve it. That point we've already dealt with. The second claim is, if this angle is sufficiently small, the object in the distance starts to disappear from the bottom up. Now there's no logical reason for why that should be the case, but what we're going to do is calculate this angle for the Mons Hill and for the island of Inchkeith, or at least the top of the lighthouse, to the top of the lighthouse on Inchkeith. So Mons Hill is 115 metres tall according to Ordnance Survey maps, and it is 48.4 kilometres away. And if we apply those figures, we get an angle of 0.136 degrees. We're ignoring here the fact that my camera was maybe 3 metres above the height of the water. That bottom 3 metres won't make a great deal of difference. Now the island of Inchkeith with the lighthouse, the focal height of the lighthouse above the water is 67 metres. It was high tide, so maybe that would be a bit less, but not much. And again, you know, dealing in general terms here, just to get pretty accurate but approximate figures. And we get an angle of 112 degrees. Oh, sorry, 112 degrees. 0.112 degrees. I said I wasn't very good at math. Okay, so the viewing angle to the top of the Inchkeith lighthouse is less than the viewing angle to the top of Mons Hill. But the flat earthers claim that the smaller this angle, the less of an object you ought to be able to see. Yet we see part of the lighthouse quite clearly, and we don't see any of Mons Hill. So clearly this argument is simply not borne out by what is actually observed in reality. Angular resolution for the unaided eye is said to be 0.02 degrees, so the angular resolution argument doesn't work either, because 0.136 and 0.112 are both clearly much larger than 0.02 degrees. And in any case, I was using a camera with a zoom and a telescope or a pair of binoculars would have the same effect of greatly increasing the resolution for our observation. Just out of interest, if you apply the standard formula for determining angular size to the same two objects, you come out with exactly the same answer. So in summary, there is clearly no sign of Mons Hill between the camera and the setting sun. If the Earth was flat, we would expect to clearly see Mons Hill on the horizon between us and the setting sun. The viewing angle to Mons Hill is 0.136 degrees if the Earth is flat, so it should be visible even with the naked eye, and with a camera zoomed in on the setting sun and the horizon, there should be no problem seeing Mons Hill at all. This leads to only one conclusion: Earth is not flat. Furthermore, these turbines are 29.5 kilometres further away than Mons Hill from the camera. They're around 100 metres tall as well, just like Mons Hill. And yet they can be seen clearly. So angular resolution does not explain why Mons Hill is not visible. Once again, we have to conclude: Earth is not flat. The arrow points out Inchcleith Lighthouse. The viewing angle on a flat Earth would be 0.112 degrees, and it can be seen. The viewing angle on a flat Earth to Mons Hill would be 0.136 degrees, but it cannot be seen. So the acute viewing angle does not explain why Mons Hill is not visible. So once again, we must conclude: Earth is not flat. Now, in conclusion, I'd like to address this idea that the Earth is flat and the atmosphere magnifies the sun as it moves away from us at sunset, such that it always retains the same angular size. So, is that true? Does the atmosphere really magnify the sun so that it always appears the same size at sunset? This is obviously a very difficult question to address. There is no flat Earth model for the size of the sun, the distance that the sun is above the Earth or away from the Earth, and so comparing angular sizes and trying to determine whether the atmosphere is having any effect on the appearance of the sun is pretty difficult to do. However, it would be reasonable to argue that if the atmosphere is magnifying the sun, then the atmosphere will also be magnifying other things, and the extent of that magnification will be greater depending on the amount of the atmosphere through which light has travelled. So, as I say, it's very difficult to challenge the assertion about the atmosphere magnifying the sun. But we can point out that the atmosphere does not seem to magnify other things. So here I've placed a pin which in the location of Mons Hill, the highest point on Mons Hill. And if we put in a line to Mons Hill and from Anstruther and continuing on in that direction, and I'll put in some borders and labels. If we zoom in on this line, we will find that there are some other hills which ought to be very close to our line of sight, and we know the wind turbines are further to the south here, and we have clear view of the horizon. So this is Detchmont Law, which according to Google Earth is 711 feet or 217 meters high, so about twice the height of Mons Hill. Some distance further away, granted. If we continue on, there's not much in the way of marked hills until we get back here to the end of the line, and this is the highest hill, Course Hill, which is 376 meters above sea level at its highest point, and almost directly in the line of sight from Mons Hill. So should we be able to see these other hills as well? Well, we can do an elevation profile of this line, and so Anstruther on the right here and Course Hill on the left, and we can see that there is a considerable variation in the elevation in between. But Mons Hill is this first hill right next to the water here, at in fact just over 105 meters, or just over 100 meters on Google Earth. It's actually 115 meters. And the reason it's marked at 63 kilometers there, 63.8 kilometers, is because that's reading from the Course Hill end and not from the Anstruther end. So let's have a look at this, and in a program where we can draw a straight line from left to right. So here we have a screen cap, and I've put it into a different program so that I can draw a line from the observer over here at Anstruther, looking towards Mons Hill, the top of which is here. And the line of sight to the top of Course Hill is completely unobstructed. We can see just over the top of these other hills so this will probably be Detchmont Law, this will be another one near Shotts, and finally out to Course Hill. So there's a clear line of sight all the way out there. So if the Earth were flat, we really ought to be able to see this hill, Course Hill, looming up above Mons Hill by some considerable amount, even without any magnifying effect of the atmosphere. Now, if you're going to claim the atmosphere magnifies, and that it magnifies the sun more than it magnifies anything else, it must also magnify other things. So if it magnifies Mons Hill by a small amount, it ought to, because there's more than twice the amount of atmosphere between Course Hill and the camera than there is between Mons Hill and the camera, it ought to magnify more than twice the amount. And so on a flat Earth, if you're going to start arguing that the atmosphere magnifies and we have a lensing effect, a magnifying lensing effect, this should make Course Hill appear even higher in relation to Mons Hill. Clearly that's not the case, seeing as we don't see either of them above the horizon. So this suggestion that the atmosphere magnifying the sun explains why the sun sets, and why we see such a large sun at the horizon, falls into some problems, because we should expect other objects to be also magnified, and they clearly are not. If they were, then, as I say, we should see Course Hill appearing way above Mons Hill. In fact, we should see Course Hill above Mons Hill anyway. Assuming that light travels that distance, well, the sun, according to flat earthers, is many thousands of miles away, and the light is travelling from the sun to the horizon and to the camera. We can see that. So there's no reason why these hills should not be silhouetted against the light coming from the sun. So once again we have an observation made in the real world, which clearly demonstrates that the Earth cannot possibly be flat, and also provides some evidence that the extraordinary claims made by flat earthers to explain things like sunsets don't stand up. They don't have any basis in reality. They are simply made up false explanations for things that prove the earth isn't flat. Now, this has been a long video. Anybody who's made it this far, well done. I wanted to get all the kind of detail in, and yeah, they're not the snappiest and punchiest of videos, but I try to present them in a way that even the heart of thinking can actually follow. Watch out in the future for some changes to the channel. I know that the channel has a bit of a reputation, although I do sort of stop and start presenting videos sometimes for various reasons. But I do intend to change tack a little bit with the videos on the channel, and that, seeing as I've got this number of subscribers, it seems rather silly to start a new channel at 0 subscribers and trying to build it up. So the channel, there will be some changes. Look out for announcements on that front. And for anybody who wonders why I went out on this particular day to get cold and wet, trying to observe the sunset, it was actually a much nicer day than it appears from this particular zoomed in and low exposure shot. So here's the shot, the view of the setting sun, taken with a more normal kind of exposure without zooming in on the bright sun. And I had a very enjoyable afternoon driving out to Anstruther and filming this. I even encountered in the harbour, just a few feet away from me, this seal who seemed to be sheltering from the wind and the cold weather. So it was a fun day. I do enjoy doing these videos, but I think there might be fewer of the flat earth videos and a few more videos concentrating on biology, evolution, abiogenesis and other things that interest me in the future. So thanks for watching, and I'll sign off in the usual way.